Chapter 5 is about moments. ठीक है, मोमेंट में चैप्टर वाइज इट्स लिटिल शॉर्ट, लेकिन इस पे क्वेश्चंस थ्योरी में स्पेशली बहुत ज़्यादा आते हैं और एटीपी भी इससे भरा हुआ है, यहाँ पे कर लेते हैं. ठीक है, सो बेसिक आइडिया ऑफ मोमेंट is it is actually the measure of turning effect. ठीक है, if you have an object, when you apply a force, we have already discussed a resultant force will cause an acceleration. But what if I fix a point, call it a pivot? Now if I apply a force, it won't accelerate, it will rather rotate. इस rotation को हम कहते हैं कि a moment is being produced. But when we say define moment, तो remember कि definition में आप कभी भी description नहीं लिखते. You won't write it's a turning effect. If you write, you won't get any mark. So definition में you have to write it's a product of force and distance. अब ये जो distance है और ये जो force है, so distance should be perpendicular to line of action, which means अगर मैं ये diagram देखूं, ये force exert हो रहा है.
What is perpendicular direct? What
yes,
is it?
So, हाँ, exactly, perpendicular to line of action.
Sir, moment.
Yes, so basically moment is defined as product of force and perpendicular distance from pivot to line of action of force. ठीक है,
so the distance is between pivot and the line of action of force.
Exactly. ठीक है,
okay.
So if this is the force that is being exerted, this is called line of action. Line of action is just an imaginary line, and it's up to you how much, no matter how much you extend, it doesn't matter because it's just a reference line. So the perpendicular distance is this one, right? This is the distance that is 90 degree from pivot to the line of action. So when you multiply this force with the distance, you get moment. Measured in Newton meter or centimeter or whatever. This is Newton and this is meters. ठीक है?
Sir, is moment like work done as well, or is it a different thing?
अच्छा, sorry, आप क्या कह रहे थे?
Sir, I said is work done related to moment because they both have the same formula.
So there's going to be a key difference in terms of force and distance. So basically, which we will discuss in chapter 7. In that case, it's F into D. You're right, both have similar formula, but that distance is the distance covered in the direction of force, and this is perpendicular. So it has nothing to do with work done because they both are completely different distances.
Understandable.
ठीक है, so we'll move forward. In this case, the object does not leave its position. Like the object is fixed. Maybe even if you close a door, so you see a door is fixed at the hinges, so that is moment. But if there's a free door, let's say if you hold a door or if you push a door and you drag along the surface, that is work done. ठीक है? So Maha, line of action is it's a reference line. I can't call line of action as the force. Line of action is just a reference line. Like if I say, for example, this is an object, this is a force being applied. So the dotted line now that I'm drawing is all line of action. ठीक है? So for example, if pivot is this point, now the distance that will be considered is this one, because this is perpendicular to the line of action of force. We have an MCQ on this, I'll share in a while. But anyway, in ARM, no, there can't be multiple line of action of forces. For now, in A levels, yes, we do. ठीक है? अच्छा. So, talking about moment, we need to discuss what is a principle of moment. Now, principle of moment is a condition where if you have multiple forces, maybe at different distances from the pivot, the idea of principle of moment is sum of clockwise moments when it is equal to sum of anti-clockwise moments, we say an object is in equilibrium.
So do you mean when it's balanced, like straight?
Yes. Sadia, over here we are talking about sum of moments. Now, let me give you an example. If we have maybe 3 forces acting, and I give you the distances from pivot as D3, F3, F2 is D2 away, and F1 is D1 distance away. So you see, this force is in clockwise direction. So if I were to write the values, I'll multiply F1 by D1. It's very important to use brackets. On the other side, if I look at force 2, this is around the pivot, it is acting in anti-clockwise direction. So F2 will have to be multiplied by D2. Now, they have used the word sum. It is for the purpose, if you have multiple forces, then what you do? You don't add these forces, you don't add these distances. What you do is, you find the moments and you add the moments individually. So you find moment of this force, which is this one. You find moment of this force, which is this one. And the moments have to be added if they uh, create the same effect, like clockwise or anti-clockwise. Is this clear? That is why we use the word sum over here.
जी sir.
ठीक है सादिया? अच्छा, ठीक है यूसुफ. So anyway, so ये जो आपका क्वेश्चन सम के हवाले से था. So principle of moment है. So rather than solving a simple example, I would say कि after I'm done going through all the important points, we will straight away look at few past paper questions. ठीक है? अच्छा, principle of moments के बाद एक topic है, that is center of mass. अच्छा, अच्छा मैं एक काम यहाँ पे कर रहा हूँ, आई एम स्किपिंग द डिस्क्रिप्टिव पार्ट ताकि हम कॉन्सेप्ट्स पे ज़्यादा फोकस करें, बट एट द सेम टाइम यू आल्सो नीड टू हैव, आई थिंक आप लोगों के पास मेरे नोट्स शायद होंगे कि नहीं, जो डू यू हैव एक्सेस टू माय नोट्स कि नहीं, आप लोगों के पास हैं इन चैप्टर्स के, वो ज़रूर गो थ्रू कर लिया करें, नहीं है
Sir,
तो आई विल
no.
अपलोड. अच्छा,
No,
आपके
sir.
नहीं, अच्छा.
Sir, is it like the whole course notes or just specific chapters?
Actually, I don't have any notes in compiled form, लेकिन इसी तरह मेरे जो नॉर्मल 4 month कोर्स है उसके नोट्स मैं यहाँ पे पेस्ट कर दूंगा.
Okay,
गूगल
sir.
क्लासरूम, ठीक है। तो बिकॉज मेरा फोकस क्रैश कोर्स में कॉन्सेप्ट्स और पास्ट पेपर्स पे है कि की पॉइंट्स जो हैं या कोई इश्यूज हैं, बिकॉज ऑब्वियसली इट्स नॉट योर फर्स्ट टाइम। तो मैं चाह रहा हूँ कि हम ये डिस्कस कर लें, ठीक है। बिकॉज अगर मैं एक एक पॉइंट लिखूंगा तो इट विल बी टाइम कंज्यूमिंग, वी वोंट बी एबल टू go through a chapter in a single day. Anyway, सेंटर ऑफ मास की अगर हम बात करते हैं, सेंटर ऑफ मास की डिस्क्रिप्शन ये होती है, it is a point at which entire weight of the object appears to act. For regular shape objects, it lies at the geometric center. ठीक है, अगर बिल्कुल परफेक्ट स्फीयर है, बिल्कुल सेंटर में इसका सेंटर ऑफ मास होता है. And how can we tell? If you place pivot right below the center of mass, we say it is balanced or it is in equilibrium. Reason कि ये जो center of mass है, it passes through the pivot, which means कि इसका कोई moment नहीं बन रहा. ठीक है नाम, I'll answer your question in a minute. Similarly, देखें center of mass से weight तो center पे ही act करता है. What if I place the pivot over here? Now there is a distance, a perpendicular distance, and this object will now fall in this direction. Okay, so we say that it is unbalanced. So it appears कि object का जो mass होता है, जहाँ पे weight act करता है, it always lie at the center for regular shape objects. ठीक है? In reality, हर particle का अपना weight होता है. लेकिन जब आप इसको कंबाइन करते हैं, उसके इफेक्ट्स देखते हैं, दे ऑल एक्ट इन सच अ वे, इफ यू कंसिडर नॉट द इंडिविजुअल पार्टिकल्स एंड इफ यू कंसिडर वन सिंगल ऑब्जेक्ट, उसका वेट सेंटर पे एक्ट करता है. ठीक है. Inam, you have a valid question. Is center of mass different from center of gravity? Well, till O levels or A levels, yes, they are similar. But beyond A levels, we don't treat them similarly. For very large objects like mountains, the center of mass and center of weight are different. ठीक है. लेकिन यहाँ पे अगर आपको कहीं पे center of gravity भी नजर आए तो it's fine. ठीक है. यहाँ पे आप सेंटर ऑफ मास का ही लिख लिया करें. एनीवे, रेगुलर शेप ऑब्जेक्ट्स का तो इशू नहीं है कि आप बिल्कुल उसका, लेट्स से इफ यू हैव अ सिलेंडर एंड एग्जैक्टली सेंटर पे you apply a force, you point, you label a point, तो वहां पे इसका weight act करता है. The problem arises when you have an irregular shape object.
So like the shape L or something.
Yes, exactly. So maybe I have a thin lamina. A lamina is just a thin sheet of paper, but irregularly shaped. Now, for this, what we do is, I won't write all the steps. I'll just go through them verbally. Then you may refer to the recording later on. The first step is you make a hole. You attach, yeah, you hang this through a pin. So if I look at a side view, this is maybe an iron stand. We have a clamps. I have this needle which I have held through this clamp. So I'll place this lamina. Lamina is just a thin sheet. So the side view, I won't see the entire shape of it. I'll just, a thin layer will be visible. So I've hanged this through a needle. The next step is, step 2, you attach a thread and hang a heavy object like a metal bob, a pendulum. This is what you do, that you attach this in front of it. Third step is you draw a line along the thread, but you have to wait till it settles. It should be hang freely, which means it should rotate. It should be able to rotate. But you need to draw these lines when it's completely stable. This line is known as a plumb line. Now, what you do next, you repeat the same steps, but from a different point. Like you rotate. I can't replicate the exact shape, but you get the point. Okay, you need to rotate. For example, you have rotated clockwise. The initial hole was here. The initial plumb line was drawn like this. You repeat the same step, make another hole, hang it through the pin, attach the pendulum, make another plumb line. This is the first one, and now this one is the second one. Where the two plumb lines meet, that is the center of mass. ठीक है? Sadia, it can be at the center if you want to make this hole wherever, like it's not necessary, but preferably it is towards the edges, like wherever you want, but to the edge, because it's easier to hang from an edge and it will settle quickly when you draw it, when you make a hole or puncture a hole towards the edge. ठीक है? Is this fine? Okay, this is how you find center of mass of irregular shape object.
Sir, what about a shape like this?
Acha, sorry, I was away on a phone call. Was out of
Sir, what about a shape like this?
So a shape like this, you can opt for a similar method. ठीक है? So you make a hole over here and you make a hole over here, but obviously the two lines might not meet, which means the center of mass might be somewhere
Sir,
over here.
no, like a solid object. There was a few MCQs on this. They're like solid objects are like, what is the center of mass or something?
Achha, so in case of, yes, so that is an important point. In case of MCQs, you need to reject few. They'll give you a hint. For example, they might give you a very random object, right? And they'll say they have balanced at this point, and you have four options where the center of mass may be. So where it has balance and center of mass is usually above. There was another MCQ where they balanced an object by attaching a mass on one side, which meant the center of mass must be over here, because this is how they have counterbalanced this object. Okay? The moment created by weight has been balanced out by the moment created by this mass m1. So in those cases, you'll be given some hint. So look into those questions. Okay? We don't have a specific method where they'll just give you an object. They'll ask you to find center of mass. Okay. So let us solve a few questions related to it so that this idea is clear. So anyway, the last point in this chapter is about stability. Like what makes an object stable or what makes an object fall. So first of all, you need to realize that objects fall if the weight does not pass through the base area. So for example, if I have an object over here, there is a weight, this is the base area. So right now the weight is passing through the base area, so it won't fall. Even if you tilt it slightly, right? it still won't fall. Reason being, the weight, if I draw, because weight has to be always drawn vertically, it is still, though it's at the edge, but it's just about to fall, but it won't fall, it will return, because the weight is still passing through the base area. But if I have a situation where I have tilted the object so much, if this is the center of mass, if I draw the weight, the base area I've left on left side. Now, in this case, in the second case, the object would have returned, and in this case, the object falls. Okay. So, if you want to know about when will object fall or when will it return, it's not possible to discuss until unless you know about the center of mass and you know if the weight passes through the base area or not. Okay? This is how objects fall or return. It's all about weight passing through the base area or not. You need to understand this point acts as a pivot. Okay? Is this point clear about objects falling or not? It's usually
जी
asked
sir.
in the MCQs. Acha. The last point of this chapter is how to increase stability in objects. Well, there are two ways to make an object stable. For example, if I have this object having a normal center of mass over here, either you increase the base area. So rather than having an object in this way, you make the base area. So you reshape the object, but without the base area. So this was the initial base area, and this is the new base area. This is how you can increase the stability. The other way to do is you have the same object and you use more mass towards the base, which will allow, because center of mass is actually the average of where most of mass exists. So if you lower the center of gravity, this will also help in increasing stability. Okay? So in different situations, there are instances where center of mass has to be lowered in order to gain stability. Like you may look into Formula One cars, etc. They have such low height because they want to lower the center of mass, and they have wider bases so that that further increases the stability. Okay? So let me share a few past paper questions. अच्छा MCQ 1 का वो कह रहा है कि which single item can be used to find the center of mass of a plane lamina of irregular shape. इसका क्या आंसर होगा?
D.
Yes, it will be D.
A vertical pin.
हाँ, वर्टिकल पिन देखिए, वर्टिकल पिन पे ये होगा ना कि फॉर एग्जांपल उस पॉइंट पे it won't fall. So if you balance, if just in case you are able to balance, so this vertical pin can help you find the center of mass. So one way to do is use proper steps जो मैंने discuss किए थे. If you don't use them, just place pin at different locations where the object doesn't fall, it means that is where the center of mass lies. What about MCQ 2?
Sir C. B
Exactly.
or C? I don't know.
देखिए, weights are needed to lower the center of mass, ठीक है, below the top of the rod, so it becomes more stable. So if you have more weights downward, it will be more stable, ठीक है. They won't raise weight of the model, increase करने से कुछ नहीं होगा. So we usually add weights to lower center of mass. अच्छा, this was recently asked, ये 2020 में. An important question on the concept of moments actually. इसका क्या आंसर होगा?
C.
D.
सी कौन कह रहे हैं? हाँ, अरबाब हुसैन.
जी सर C.
हाँ, so basically देखें, मैंने क्या कहा था कि moment is product of force and distance. लेकिन this distance is from line of action. अब ये pivot है. Q is pivot. If I draw a line of action, this is the entire line of action of force. Now, if I consider Z, Z is not perpendicular to the line of action. Even W is not. X is completely parallel, which is incorrect. The Y is only, this is the only distance which is perpendicular to the line of action. अच्छा, अगर आप आंसर करते हैं तो को होस्ट में दें, ठीक है? मुझे को होस्ट वाले नजर आते हैं. Is it clear?
G, sir.
Okay, the distance has to be perpendicular to the line of action. तो simple terms में this is the ये पूरा line of action होता है, and this is the perpendicular distance. So F into Y. This is the simplest possible. So you don't have it into force क्योंकि दोनों साइड पे forces ही हैं. So you can simply multiply 25 by 1.2 x into 1.5. ये तो बहुत simple question.
Sir, wait. What will the mass be? The same as child P? Because they're the same mass.
The distance is different, so I
Oh, I
expect
didn't see
the
that.
mass to be
No,
different.
I didn't see this.
ठीक. अच्छा, what about this one? Can you give it a try? अच्छा, ठीक है अरबाब हुसैन, let me give it a try. They are saying कि and P remains on the ground, which means this acts as a pivot. If you lift this object, तो ये तो pivot हो गया. So we have two forces, F into 3 is equal to weight, which is 600, and it acts at this, because they have already labeled this, 600 into 1. So we get 200. ठीक है?
सर इस ऊपर वाले में
Again.
weight सर ये ऊपर वाला था सर, इसमें वेट अब पी में एक्ट कर रहा होता है कि हम इसे मल्टीप्लाई करते हैं 1 के साथ 600 के साथ।
ये जो यहाँ पे पी का क्वेश्चन है आपका?
जी से जो आपने अभी किया है।
अच्छा नहीं, देखिए वेट एक्ट करता है सेंटर ऑफ मास पे।
अच्छा
तो विदाउट इवन लुकिंग एट द क्वेश्चन कि क्या पूछ रहा है क्या नहीं पूछ रहा, देखिए मैं कैलकुलेशन से पहले अगर वो मुझे कह रहा है सेंटर ऑफ मास जी है और इस ऑब्जेक्ट का वेट 600 है, मैं सबसे पहले यहाँ पे एक फोर्स लगा लूंगा 600।
सही है सर।
और उसने फिर कहा कि एंटी मूव नहीं हुआ ना, रिमेन्स ऑन द ग्राउंड, विच मींस ये पिवट बन गया, बाकी ऑब्जेक्ट इसके अराउंड रोटेट हो रहे हैं।
अच्छा
So 600, 1 into 600 divided by 3.
Yes, because 600 into 1 is, you see, this is a clockwise movement around the pivot, and this one around the pivot is anti-clockwise. So 601 is equal to F into 3.
Okay, sir.
नहीं सादिया, इसको मैं सेम डायरेक्शन नहीं कहूंगा। देखिए हाँ, सेम साइड पर हैं, पिवट के राइट साइड पर हैं, लेकिन दोनों का इफेक्ट ऑपोजिट है। एक नीचे एक्ट कर रहा है, ठीक है, विच मीन्स कि ये इस ऑब्जेक्ट को रोटेट करवा रहा है इन अराउंड द पिवट, ये क्लॉकवाइज आ रहा है। बट इफ आई कंसिडर पॉइंट क्यू देन आई इग्नोर जी। इसका अगर मैं देखूंगा ना तो ये अराउंड द पिवट एंटी क्लॉकवाइज जा रहा है, ठीक है। तो आपने ये नहीं देखना कि पिवट के राइट साइड पर है कि लेफ्ट, आपने ये देखना है कि ये क्लॉकवाइज क्रिएट कर रहा है कि एंटी क्लॉकवाइज। अगेन ये हमारे पास स्टेबिलिटी का क्वेश्चन है, बाद में देख लें। इसका आप बताएं, ये 1-2 साल पहले थ्योरी में भी पूरा क्वेश्चन इस पे डिजाइन था। ये इम्पोर्टेंट है, ये सॉल्व कर लें अभी, आपके ख्याल में इसका क्या आंसर होगा?
Sir, 54.
We'll find out। देखें सेंटर ऑफ मास इसका 70 kg mass था, so 700 Newton will be acted on at this point।
जी sir, I did that.
और यहाँ पे आपने इसको 60 न्यूटन कर दिया इंटू 10 करके, एंड फोर्स वो मांग रहे हैं। तो देखें एंड ये पॉइंट पिवट है, तो ये पॉइंट मूव नहीं कर रहा ना, बाकी बॉडी मूव कर रही है। सो
So you have to
पुशअप्स,
identify the pivot as well.
यस।
Uh,
सो देखें आप खुद नोट करें ना, लुक एट लाइक ये प्रेसअप्स जो होते हैं या पुशअप्स जो होते हैं, इसमें अगर आप नोट करें योर एंटायर बॉडी इज मूविंग, बट ये जो टोज हैं बिल्कुल फिक्स होते हैं, ये मूव नहीं करते। आपने नोट किए, पूरी बॉडी रोटेट होती है अराउंड। सो दे हैव मेड दीज क्वेश्चंस स्लाइटली डिफिकल्ट नाउ, अभी टू 2020 एंड ऑनवर्ड्स। इसमें आपको पिवट पाजा को नहीं मेंशन करते किधर, आपने खुद थोड़ा सा सोचना है।
okay, sir.
सो देखिए, isn't 700 around the pivot anti-clockwise? तो
सर सी होगा।
अच्छा मैं चेक कर लेता हूँ, आई डोंट हैव द आंसर राइट नाउ। 600 को मैं किस डिस्टेंस से मल्टीप्लाई करूँ? 60 को
Sir, 0.1.
किससे?
No, sir,
0.1.
1.2।
1.2, yes.
1.2 पिवट से डिस्टेंस 1.2 है।
Oh,
और फोर्स जो है, बिकॉज देखें यू द रीजन व्हाई वी डिस्कस द डेफिनेशन इन सच डिटेल, क्योंकि आप definition clear हो तो you can always refer to the definition in complicated questions. And this force has to be multiplied with 1.3, right? The total distance 1.3 है.
Yes, sir.
तो f की वैल्यूज के मुताबिक कितनी आ रही है?
सर सी है
जी
please.
बिल्कुल. अच्छा